Hi, good evening, I guess. Good afternoon. Let's just start. We started developing Detox a bit over a year ago out of a need for a tool we can trust with our own E2E tests on our own application. We had a big problem where non-deterministic test runs were too common in our CI, and we couldn't rely on our own test suites. We spent too much time maintaining them. After a year of building and using it as a part of our development and release process, we've gathered a few insights, and I want to share them with you today. So a bit about me. I'm Rotem. I'm a software engineer at Wix. I'm a part of a mobile infrastructure team. My team works mainly on does infrastructure work, defining and building development and integration, the integration process. We devote a big chunk of our time for testing infrastructure and methodologies and building better environment for our developers. The unique thing about the work that we do is that most of it is open source. So let's just dive in. Flakiness. E2E tests are often considered to be flaky in all platforms, web, iOS, and Android. Tests may fail without any code changes. Non-deterministic tests, there are too many moving parts inside the app, and some of them may be finished executing in different orders and get different results on screen and on different environments, like on your computer and on CI on different operating systems. Uncontrolled inputs may vary between tests as well. So I could have an A/B test in one test, and the other test would be the other A/B test would be on the other test. So we can't really be sure when the application is idle. So users of end-to-end frameworks often have to deal with this synchronization manually. So they use multiple sleep functions in strategic locations just to make the tests pass. In fact, we embraced that fact so much that E2E is flaky, and we created patches, just patches on patches. And so we sleep and retry, and we sleep and retry. How unreliable a flaky test suite is, actually. So let's calculate the probability of a test suite to fail. Y minus Q is the probability of a single test to succeed. 1 minus Q at the nth power is the probability of the entire suite to succeed. And y minus all that is the probability of at least one test to fail. So if we'll just take an example, we have a test that is flaky just 0.5% of times, and we have 20 tests. We'll have about 10% of failing test suites. If we have 50 tests, it's around 22%. And, well, when 100 tests, you get the point. It's very unreliable. So we used Appium for 2 years in general and 8 months with React Native. And we found that we've invested a lot of time writing the tests and petting the system than actually writing code. We found that end-to-end testing was really hard. Tests are flaky and got different results on different machines and frequent failures in CI. And the only solution was just the addition of those slips we talked about, which, of course, slow down our tests. And so the benefits have outweighed the cost. And frameworks which are complicated and fragile can occupy a very big chunk of our time. So the main characteristic of frameworks of this kind is that they're all black box. What is black box testing? It's a method of testing stuff from the outside without knowing what's going on internally. In mobile, black box end-to-end essentially goes over the view hierarchy and looks for an element. If it's not found, it slips and then continues looping until an arbitrary timeout and that we choose or the framework chooses for us. And if it's found, the framework interacts with this view. Same principles are applied to web black box end-to-end. So what is the proper timeout parameter? Can anyone guess? Just 10 seconds? And any other guess? 2 minutes, OK. So think think how unfair is asking users to provide timeout parameter. They have no idea what's going on inside the application. They have no idea what's going on inside the system or even inside the application. So that's the main cause of flakiness. You can't really choose this parameter. You don't really know. So black box was a dead end for us. And with Detox, we took a different approach. Detox does Graybox testing, not black box testing. This allows the test framework to monitor the application from the inside and actually synchronize with it. So Graybox essentially is a piece of code that is planted inside the app. It can see everything that goes inside the application. So unlike black box, Graybox runs on the same process. It has access to the memory. It can monitor the execution of the process. Being able to do that, to read internal memory, it gives the ability to detect what's happening inside the process. There are which network requests are in flight, and if the main thread or other threads are busy, and what's up with animations, are they done or not, and even timers if we want. So it also can execute on the main thread and to make sure that when we actually perform the action, nothing really changes in the layout itself. But there are also downsides for this method. We usually don't test exactly what we ship. We test something a bit different, but for us it was a big win, even though it's not exactly the same application. So the leading native Graybox drivers are developed by Google, Earl Grey for iOS, and Espresso for Android. These frameworks can synchronize with the application, making sure we interact only when the application is idle. The underlying synchronization mechanism in these Graybox frameworks works the following way. So instead of retrying an action and assertion like we do in black box on the UI itself, they will query internal resources every few milliseconds or have callbacks that say that things have ended. And then they decide they switch to idle mode. The test will not continue until everything is idle. So only then, when it's idle, will interact with the UI. Detox does not rely on WebDriver because, frankly, this is not the web. Detox communicates with a native driver, which extends Earl Grey and Espresso. So we also add our own flavor of things to native code. Using a JSON-based reflection mechanism that we created, this allows common JavaScript implementation to be invoked natively, to just invoke native methods directly on the device. So this is how a simple Detox test looks like. So we don't need to synchronize and sleep, wait until stuff finishes. Detox is inherently synchronized. It will execute a command only when the app is idle. It is cross-platform. Test code is unaware of the platform it tests, mostly. There are a few special APIs for each platform. It is test runner independent. So this example is with Mocha, but we're not picky. You can choose whatever test runner you want. We also have command line support for Jest as well. It is debuggable. Using async await native constructs, instead of putting everything in a promise queue like others do, means that the breakpoint will just work as expected. So traditionally, test frameworks evaluate expectations in the test script running on a computer. Detox evaluates expectations natively on the device, directly on the tested app, running on a simulator or emulator or a device. This enables operations that were impossible before, like querying every few milliseconds and not really changing and not really having any performance impact. Let's take a look at the high-level diagram of Detox. With this example, I hope you can understand how it works. So the test runner itself is the code that you write. So an action or an expectation is then being serialized into a nested invocation JSON. And then the server relays this message. It's just a JSON message to the testee. The testee is actually the device or simulator. The testee, the action and the expectation, is invoked through method reflection on both iOS and Android. It's quite the same. The invocation will only execute when the app is idle, of course. So we can just invoke it anytime we want, but only when the application stops doing stuff, it will trigger. And then the result just comes back. If it fails, then we just, the promise just fails or succeeds, and then it just stops the test runner or not. So during that year, we've been using Detox to automate and improve our release process. We've used multiple testing scenarios, crunched tons of synchronization bugs, and came to a few understandings as to what makes sense of testing with Detox, actually. One rule that should guide every test scenario is predictability. Now that everything is synchronized, predictable inputs should manifest predictable outputs, of course. So in general, there are two types of tests that we do, that we use Detox for: production E2E and mock E2E, or UI automation. The main characteristics of production E2E is that it involves every part of the system. It is the closest thing to a real user, and it has many uncontrollable variables, and each can affect the test outcome, of course. And if the network is down, the test will fail. If any servers has issues, the test will fail. If you get a different A/B test variant in each run, of course, the test will fail. So the pros of production E2E is that these tests are as close as possible to a real user experience. Logging in with user against real production servers and endpoints. They're very easy to set up. They're very easy to write. And you just find an element, interact, and expect. The API is very, very lean. And so these tests can provide very high confidence if they were not flaky and slow. The main benefit of them is that they can help QA engineers replace manual testing methods, but again, they will never be as rock solid as mock tests. So therefore, they're very hard to maintain. So mock E2E, on the other hand, tries to eliminate all that by setting controlled and predictable environments. And replacing all endpoints with a mock server or data or whatever, the server and client communication can be tested through contract tests. And by that, we can almost eliminate doing production E2E. Just a side note, React Native is very challenging when it comes to testing. Unit testing is pretty easy most of the time because you can just do it either in JS code or native code, but you just test one part of the system. And there are great tools for each platform. When it comes to testing integration between them, things become a bit trickier. Since React Native renders a native layout, but it's configured from JavaScript, mocking React Native JavaScript API results in very limited tests. Same as shallow rendering on web. So in absence of a better tool, I believe mock E2E is the best approach for integration tests for React Native. So mock E2E, the pros of mock E2E are that these are much closer to actual code, and they're much stabler because we're using mocked endpoints. So we have now controlled and predictable environments that provide the same input on every test iteration. They're very easy to maintain because once you write them, they should just work. The cons is that they require more setup because you actually have to write the server and all the configuration around it, and they're much harder to write since we need to take care of mocking and controlling everything. So Detox has a few. Detox has a few useful mocking mechanisms. I'll focus on how we mock for Detox with React Native, but this can be done with Gradle, build flavors, or with for Android, of course, or configurations on iOS. So in order for an app to use mock server, we'll need to make the app know it should connect to a different server and to a different endpoint instead of a real server. So our way of doing it is by creating a new flavor of the JS bundle, one which uses just different endpoint than the production app. So this is supported by Metro Bundler, and by creating any file .e2e.js, we can just create a custom JS bundle. So with very limited modification, React Native can also support multiple build flavors. So this is supported natively already in React Native 55. And for previous versions, you can use React Native Repackager. It actually does the same thing as React Native 55. So adding React Native Packager as a dependency and triggering it on your post-install script will just alter React Native, the actual code of React Native in your Node modules, and then adds this functionality. So let's see how it works. We'll create endpoint E2E alongside endpoint E2E, and alongside endpoint.js. And then adding our CLI config.js to rootdir and setting get source extensions will prioritize any given source extensions over the default ones. And by triggering each of these commands, the bundler will take E2E.js over any JS file. So instead of bundling endpoint.js, it will just bundle endpoint.e2e.js. So this is an actual test from our mocked E2E test suite. Mock server is an object that lives inside the test runner's node process. It can be altered during test using simple function calls. And once we set up the mock data, the test just launches the app. So now we can run mock tests, and that verifies the application can persist login information and does not show login window in subsequent launches without even going to the real server. Another method worth mentioning is testing the application output by gathering requests going out of the application and running the expectations on the mock server itself. So in case we see simple notification, so in this case, we see simple notification server that records regiscribe and unsubscribe requests. And by triggering the application and to send these requests, we can make sure that they're being sent correctly. So we launch a freshly installed app and then log in, check in that the server didn't get any device token yet. Then we click to allow, we click allow in the app. This is something that should send the message to the server using regiscribe request. And then we validate that the server got the token from the last regiscribe request. So there are a few more mocking mechanisms built in Detox. We use them in our mocked and production E2E test suites if we have to. This allows the tests to be predictable, to have predictable inputs and produce stable outputs. So we now have pretty consistent results in all of our tests. So this shouldn't even be a slide, I think. We do it when we write unit tests. So why do we need it? Why do we need to do things differently when we write E2E tests? We kind of learned this the hard way, I think. And so if you have conditional tests, like if did not log in or if shows like a welcome screen, just mock the state, and separate to 2 or more tests. So what's next for us? So Detox helps us write better features faster, and but there's still a long way for us. And so we incorporate both E2E methods in our development and release process. And that's at least where we're aiming. So setting our goal and continuous deployment, we're working very hard to lower our reliance on manual QA. So this is our approximately 0 manual QA plans to be implemented in the short to midterm. So developers write unit tests, mock E2E, and contract tests. as a part of their product development. And this is incorporated in CI, and every build on every commit runs these test suites. This shouldn't take long. It takes around 5 to 20 minutes to get a full test coverage of everything we do. And this generates a very short feedback loop for the developer. The QA engineers, on the other hand, they use Detox to actually automate the regression and progression suites. So instead of doing anything manually, they just take it and do production stuff with Detox. These tests will never be as rock solid as the other mocked stuff. And so hence they are decoupled from the process. They're not a part of the CI process itself. And scenarios are also owned by the QA team. The developers and the QA are obligated to synchronize. So the QA will educate the dev team on how to write high-quality tests, high-quality scenarios, not tests, and review mock D2E suites. And by having a good grasp of what's already covered in the mock D2E, they can reduce the amount of production E2E to the bare minimum. So back to Detox. So this is our plan for the near future. We want to support test runner parallelization. So this is something that we are trying to do for the past few months, and we're getting there. Artifact generation, screenshots, videos, and logs, and where we want to do better error logging. So I spoke with a few people here yesterday about attended my workshop, and if someone wants to PR something, it will be great. We want to run on iOS devices. Android devices are already supported, and one more. So maintaining performance is really hard. The main issue is that by the time you notice there's a performance degradation, you've changed already too much in your code base. And it's really hard to find what's the immediate culprit of this regression. So it's probably many small ones, things we call death by 1,000 cuts. But just like BI, we want to know if our change degrades or improves the performance of what we do. But we won't know that unless we measure that. So in the past year, we've been working on a performance analysis tool called Detox Instruments. It's already open source, and it is designed to help developers to profile their applications. It's a Mac application. And our biggest plan this year is to actually automate performance probing, running performance analysis on each E2E test in CI. This should give us a pretty good insight of where things go sour. I'm writing about Detox and other React Native related stuff on my Medium. Follow, clap, or don't, though I do mind. Thanks.